Hello everyone, today we shall discuss question number 2.9 of motion in a straight line. Explain clearly with examples the distinction between magnitude of displacement, sometimes called distance over an interval of time, and the total length of path covered by particle over the same time interval. Magnitude of average velocity over an interval of time and the average speed over the same interval. Average speed of a particle over an interval of time is defined as the path length divided by the time interval. So in figure A and B, the second quantity is either greater than or equal to the first. When is the equality sign true? For simplicity, consider one-dimensional motion only. Let us find it the solution here. Here we are going to solve in this way that solution. What is the solution? That is the magnitude of displacement over interval of time is the shortest distance. The magnitude of displacement, the magnitude of displacement, the magnitude of displacement over an interval of time, over an interval of time, over an interval of time, over an interval of time is the shortest distance, is the shortest distance, is the shortest, is the shortest distance, is the shortest distance which is straight line, which is a straight line, which is straight line, which is a straight line between the initial position, between the initial and final position, between the initial and final position, and final position of the particle. This is the displacement of the particle. The total path length of a particle, the total path length of a particle, the total path length of a particle moves from point A, moves from point A to point B, and then comes back to a point C, taking a total time t, as shown below. Then the magnitude of the particle AC, then the magnitude of displacement, then the magnitude of displacement, of the particle is equal to AC. Suppose this is the position of A, this is A position, this is B position, comes back to C, and AC is the magnitude of displacement, right? And whereas total path, whereas total path length equal to is equal to AB plus CB. AB plus CB this is the total path. AB plus BC you can say, or same thing, what I am writing AB plus BC. AB plus BC. This is the total path length. A plus BC. Right? It is also important to note that the magnitude of displacement can never be greater than the path length. It is also important. It is also important. It is also important to note that the magnitude of the displacement the magnitude of displacement displacement can never be greater than the total path length, can be greater than the total path length. This we know. However, in some cases, if we take another cases, let us see what is the case. Suppose we are taking this case. Here you can see another important thing that however in some cases in some cases both quantities are equal to each other. Both quantities are equal to each other. Both quantities equal to each other. Equal to each other. And now we'll do the question number B. Magnitude average velocity over the interval of time and the average speed over the same interval. Magnitude and average speed. What is the difference? You see here that magnitude of average velocity, magnitude of average velocity, magnitude of average velocity is equal to magnitude of displacement by time interval. Magnitude of displacement by total time for the given particle average velocity equal to average velocity equal to AC by T. For this figure we already told you from A to B and B to C. This is C. So average velocity will be AC by total time taken, right? And average speed equal to average speed is equal to total path length by total time interval. Total path length by total time. So the total path length will be AB plus BC by T. This is average speed and this is average velocity. Average velocity is displacement by time and this is by total path length by time, that is average speed. Since AB plus BC is always greater than AC, average speed is greater than the magnitude of average means average velocity, the two quantities will be equal. Will be equal if the particle continues to move in along a straight line Thank you everybody for watching this video.